Ever since Galileo discovered the moons around Jupiter in 1610, they've been exciting places to think of, maybe as planets all of their own. In 1975, yeah, that's me, it was the 70s, I wrote my master's thesis about modeling how the interiors of these bodies would evolve with time with radioactive heating, and I predicted that Europa should have a hot, rocky core, a liquid ocean, and a thin ice crust. After me, JPL came up with prettier pictures with that idea, and then actually got images of the ice flows on the surface of Europa itself. I presented my idea at a meeting in 1975 where I ended with the sentence that ends my master's thesis: we stop short of postulating life forms in these mantles and leave such to others more experienced than ourselves in such speculations. I was thinking of Carl Sagan. Well, it turns out Carl Sagan was at that meeting. He was the chair of the session. And he pointed out two things to me. First of all, if you've got an icy crust, there's no place for sunlight to get through the ice to power the energy needed to make life forms work. And secondly, with a crust like that, how would you even know if there was life under the crust? Well, a few years later, we discovered in the darkest parts of Earth's oceans tube worms like these that get their energy from volcanic plumes, just like I predicted should happen at the bottom of Europa's ocean. And we have actually seen water coming out of Enceladus and evidence of water like that coming out of cracks in the Europa's crust as well. A paper has actually been written, much better than my hand-waving science fiction, about the idea that Europa should be habitable. And this idea is now so well established that there are now missions, one from Europe, the ESA Jupiter Icy Satellite Explorer, and the NASA Europa Clipper, that will be looking exactly for life forms like this. If they don't find it, I think follow-up missions will. That's where I think we're going to find life in the universe.